So let's go ahead and finish up our work with linearizations. And we talked about that we could tell if we were going to have an overestimate or an underestimate by knowing what the function looks like. And we want to know if the function's concave down or concave up. And you'll see that as we get working with derivatives, that derivatives will be able to tell us the concavity of the graph. Okay, so I remember two little things. That this one is concave down. Let me get a different pen. So it's concave down like a frown. Okay. Concave down like a frown. This one is concave up like a cup. Let's see if I can draw a little cup here. Yeah, sure. That's it. That looks like a cup. Okay, so that's how you remember if something's concave down or concave up. Okay, so now let's put in here, how can you determine if a linearization is an overestimate or an underestimate? Just from the graph. Okay, so I'm going to put in the graph that we just had. And we can see that that graph is concave down. And we had our tangent line. Oops. And I'm exaggerating it a little bit so that you can see that it is above the graph. Okay, and I'm going to say that, since f of x is concave down, the linearization, which again is just the tangent line, will lie above the curve. Well, if it's above it, thus it's going to be an overestimate. And even though it's an overestimate, we saw that they're really, really small. Okay, so let's go ahead then and see what happens. What if we used our linearization, the one that we just did, to estimate the square root of 25? Now remember that we found it at 9. So if 9's right here, 25 is down here somewhere. So we should get an overestimate, and it shouldn't be very accurate because we're really far away from the center of our linearization. Okay, so I'm just going to put that in for x. And that's going to be approximately 5.66667, 5 2/3. Well, we know the actual. We know the square root of 25. So, I mean, it's not horrid, I guess, but for math, we're going to say, no, we don't like that. It's not good. Okay, and then the reason is because 25 is too far away from 9. So we want to make sure that we're always looking at, is it appropriate to use that linearization? And again, I want you to think about that we call this linearization, we say it's centered at 9. And that makes sense. Okay, that's the point that we used. Is not a good approximation. So we saw that if we did like 9.1, that worked out really nice. 25, not so much. Okay, now there's a formula that you're going to see for a linearization. And again, if you try to memorize all of this stuff, way too hard, but let's look at what we already know. So if we have a linearization, and we're going to say that the center is at A. And watch out for that. I recall a test last year or the year before where I asked them to give a linearization, and I said the word center instead of find the linearization of f at x equals 9, and I said find the linearization of f centered at something. And a lot of kids were like, well, what does that mean? Okay, so just be aware that you might be given, it might be called the center. Remember that is just a tangent line. Of f at A. Okay, and I want you to see, because they give us a formula that doesn't look like what we're expecting. Okay, so I want you to think about if we have a tangent line and we've got some point A. Okay, well, we know that there would be a point A, f of A, right? And what would be our slope of the tangent line at A? How about f prime of A? Because we said that the slope is just the derivative. Okay, so here's my point. Here's my slope. And I'm going to plug it into the point slope formula. And I'm going to do the new one where we put y1 over on the side. Okay, now, and instead of writing y, I'm going to write f of x equals, we said the slope, which is f prime of A, times x minus A, because x minus, there's our point, plus f of A. Okay, because remember, this is x1, y1. So there's the slope, x minus x1 plus y1. Now, that's the way that we've been writing them, and it's the way that I prefer to do it. But I believe that your book then turns around and says, no, you know what? I think I would like to write it like this. And they just move that to the front. I don't know why. Okay, So you're going to see that formula. And I want you just to say, okay, that's the equation of the tangent line at the point A. Okay, so this is the tangent line approximation. Sometimes you'll hear it like that. Okay, it's just the regular tangent. Oops. It's just the regular tangent line. Okay, nothing different there. All right, we will stop there.